Okay, hello everyone. In our last class, we have been discussed Laplace transform of some elementary functions. In detail, we have been discussed. We discussed uh, about 16 uh, elementary functions and its corresponding Laplace transformations. In detail, we have been discussed. This one is the 15 and this one is your 16. In our today class, we are going to discuss properties of Laplace transform and corresponding some numericals. Okay, so let's start. First property is your linear property. If c1 and c2 are constants and Laplace transform of f1t, small f1, here I written small f1t and small f2t are capital F1s and capital F2s respectively, then Laplace transform of C1 F1t plus C2 F2t is C1 F1s plus C2 F2s. In mathematical, we can write this is the symbol of Laplace transform. Laplace transform of this one will be equal to this one C1 F1s plus C2 F2s. Now we are going to go for proof. Okay, so we know that the Laplace transform of f1t is nothing but e to 0 to infinity integration e to the power minus st into f1t dt. Likewise, for f2t will be e to the power minus st integration of 0 to infinity into f2t dt. Now we are going to add. Now we are going to consider Laplace transform of c1 f1t plus c2 f2t will be equal to integration from 0 to infinity e to the power minus st of this one. So c1 f1t plus c2 f2t into dt. Now I am going to segregate these two functions with two integrals. So here e to the minus st c1 f1 dt e to the minus st c2 f2t dt. So here c1 and c2 are the constant, not the function of t. So can be taken outside the integration c1 0 to infinity e to the minus st into f1 dt. Here also c2 can be taken outside the integration. Now c1 and this one is nothing but your Laplace transform of f1t. This expression is nothing but Laplace transformation of f2t. So we can write that imply Laplace transform of this one is equal to c1. This one is nothing but Laplace transform of f1t, or we can write capital F1s plus c2 f2 capital F2s. F2s is nothing but Laplace transform of f2t. Hence proved. In general, we can write Laplace transform of summation of m equal to 1 to n cm fmt will be equal to summation over m equal to 1 to n cm capital F of m s. Okay, if I'll be open the summation bracket, then I can write in this format, that is your c1 small f1t plus c2 small f2t, like this. And here right hand side will be c1 capital F1 s plus c2 capital F2 s, like that. Okay, so now we are going to go for the uh, simple numericals based upon the linear property. Okay, this one is your first one, Laplace transform of 8t, which is based upon the linear property. By linear property, we know that Laplace transform of ft, that means if a is constant, will be taken outside, and Laplace transform of ft. So a into capital Fs. So here Laplace transform of 8t, 8 is the constant, will be taken outside. Here this one will be 8. Okay, 8 into Laplace transform of t. Already we have been discussed that Laplace transform of t is nothing but 1 by a square. You can check if that in our last class, when we discussed the elementary functions and its corresponding Laplace transform of t is nothing but 1 by a square. Okay, so 8 into 1 by a square. So the answer will be 8 by a square. Now another question, 2 into t square plus 3 into t cube Laplace transform. So here we can write Laplace transform of 2t square, Laplace transform of 3t square, 2 and 3 taken outside, and here t square Laplace transform is nothing but gamma 2 plus 1 by s to the power 2 plus 1, because in general we have been already discussed in our last class t to the n, Laplace transform of t to the n. I am going to show you here. Laplace transform of t to the n. Laplace transform of t to the n is your what? N factorial by s to the power n plus 1. Okay, so or we can write gamma n plus 1 by s to the power n plus 1. So same thing I have written, gamma n plus 1 by s to the power n plus 1. For this case n is your 2, for this case n is your 3. Okay, so that implies Laplace transform of given function, this one 2 t square plus 3 tq equal to 2 gamma 2 plus 1 is nothing but your 2 factorial by s to the power 2 plus 3 cube, s cube plus 3 into gamma 3 plus 1 is nothing but 3 factorial by s to the power 4. So this will be the answer. Now we are going to go for the next property, that is your change of scale property. This is very very important, oftenly asking in your exam for 2 to 3 mark to prove. So carefully you have to write down your note and accordingly you have to prepare for your exam. So if Laplace transform of ft equal to fs, capital Fs, then Laplace transform of f of at, here a is multiplied with t inside this bracket, will be equal to 1 by a capital F of s by a. Okay, now we have to prove this one. Prove Laplace transform of f of t. In general, we can write 0 to infinity e to the minus st into f of uh, at dt, because the function is your f of at. Now at is taken as u. That implies t will be u by a. And if I am going to differentiate both the side, then a dt equal to du. That implies dt equal to du by a. Now we are going to substitute over here. So Laplace, that implies Laplace transform of f of at equal to 0 to infinity e to the power st. Instead of t we have to write u by a into f of at, f of u into dt will be substituted by du by a. Okay, here dt equal to du by a. Now here you can see a is the constant, will be taken outside the integration 0 to infinity e to the power, here u by a can be written as minus s by a into u into f of u into du. Okay, Laplace transform of f of t, that implies will be equal to 1 by a. This is nothing but what? This is will be f of s by a, because Laplace transform of f of t, if I am going to consider, that is nothing but 0 to infinity e to the power minus st into f of t dt, which is nothing but f of s. So here s is there, we have to write capital F of s. So if here s by a or something will be there, so here s by a will be there, means we have to write capital F s by a. So hence proved. Okay, okay. Now we are going to solve some numericals based upon this property. If Laplace transform of cos square t equal to a square plus 2 by s into s square plus 4, then find cos square 3t. So this question based upon the change of scale property. So we know that the Laplace transform of f of a t equal to 1 by a capital F of s by a. So in the question it has been given that Laplace transform of cos square t equal to this much, a square plus 2 by s into a square plus 4. Now here instead of cos square t we have to find out cos square 3t, that means at. So at means instead of s we have to write s by a, and then also initially we have to multiply 1 by a. So what will the answer? 1 by 3 whole into, here s is there, s by 3 square 2 plus 2, here s is there, s by 3 into a square, instead of a square s by 3 whole square plus 4. Then if I will solve it, then this will be a square by 9. If I will add a square by uh, uh, x square plus 9 into 2, 18 by 9. And if I'm going to consider this, see this 3 got cancelled, so here this will be 1 by s. Okay, and this if I will add this one, then this will be a square plus 36 by 9. So 9 got cancelled, so we found Laplace transform cos square 3t will be equal to 1 by s into a square plus 18 by s square plus 36. This is the answer. Now this is somewhat important question. Carefully you have to watch. If Laplace transform of sin at by t equal to tan inverse 1 by s, then find out Laplace transform of sin 2t by t. Okay. Likewise, we have tried that by change of scale property, we know that Laplace transform of f of t equal to 1 by a into f of s by a. So hence, Laplace transform of 2t by t, 2t by t, we have to find out for 2t by t. In this way, we can write that. So hence, Laplace transform sin 2t by t can be written as Laplace transform to sin 2t by 2t. Here 2 multiplied and 2 divided. So is equal to 2 into Laplace transform of sin 2t by 2t. We can write. So here we found Laplace transform sin 2t by t is nothing but 2 into Laplace transform of sin 2t by 2t. Here it is given in your question that Laplace transform sin t by t is your tan inverse 1 by s. So therefore this value will be how much? Already 2 is there. So Laplace transform of 2t by 2t. We have to apply change of scale property upon this. T by t, sin t by t tan inverse 1 by s, sin 2t by 2t will be how much? 2 already multiplied is there, 2 we have to write. For this a is 2, so 1 by a, that means 1 by 2 tan inverse 1 by, here tan inverse 1 by s, so we have to write 1 by s by a, so tan inverse 1 by s by 2. Okay, so that implies tan in Laplace transform of sin 2t by t, that implies Laplace transform sin 2t by t will be equal to tan inverse, this 2 will be go to the numerator 2 by s. So this will be the answer. Okay, now we are going to go for another simple numerical, that is your Laplace transform of sin t, given that if Laplace transform of sin t equal to 1 by s square plus 1, then find Laplace transform 4t by using change of scale property. By change of scale property, we know that f of t Laplace transform 1 by a f of s by a. So here Laplace transform of sin t, given that 1 by a square plus 1. So Laplace transform of 4t, that will be, here a is your 4. So we have to use this one, 1 by 4 into, instead of s we have to write s by 4 square plus 1. So finally we found 4 by a square plus 4 square. This will be the answer. So for you, these two questions I given, you have to do for yourself. Okay, so thank you so much for watching this video, and write down your note. I'm going to uh, uh, upload the videos regarding Laplace transform. Next class we are going to discuss shifting property and another property and corresponding numericals. Okay, so thank you so much for watching this video. Thank you.